Hey, it's Mr. Sayer. Today we're going to be talking about system of equations, okay? And we're going to be talking about how to solve those system of equations by graphing today, okay? I got 4 examples for you, and what we're going to be looking for in each of these examples are where these 2 lines or where these 2 equations are going to kind of meet up, okay? And any intersection point that we see are going to be the solutions to the problem that we're doing, okay? The first example that we're going to be working with is y equals negative 2x plus 9 and y equals 3x minus 11, okay? The solution to this will be the point where both of these lines intersect, okay? So I'm going to be using the calculator today to help me, and we're going to be looking at some of the calculator's cool functions to be able to go ahead and get intersection points for graph. Okay, so let's get started. So first of all, I'm going to enter these because they're already y equals the equations. I don't have to like move anything around, so let me just enter this in, all right? So I'm going to start by entering this negative 2x plus 9. Let's see here. There we go. And I'm going to enter my first line here, and now I'm going to enter the second one. Again, hit tab to bring up the equation editor and type in that second one. So 3x minus 11. All right, so there we go. We got 2 lines, and you can see that right here that there is an intersection point. Okay, now let me move these labels out of the way. And for the most part, what we're going to need to do is find that intersection point. To do that, what I'm going to do is I'm going to hit menu on the calculator. It's going to give me all these different options. The one that we're going to be using a lot today is analyze graph. And if you look at option number 4, it's going to say intersection. Now what it's going to ask you to do is get the lower and upper bound of the point, meaning it wants you to kind of show a little left of the point and then a little right of the point. So when I click to the left of the point here, and then it's going to say upper bound, which is to the right of the point, you'll notice there's like a shaded area, and within that shaded area, it'll look for intersection points, okay? And there we go. We got our intersection point, and what do you know? It gives us the answer, 4, 1, okay? So 4, 1 is our answer, and I'm going to write that down over here. What that pretty much means is if you plug in 4 for x and 1 for y for both of these equations, it will pretty much make both of these equations true, okay? They'll make both of them true statements, okay? Let's go ahead and try another problem. The next problem, we're not going to be so nice, or it's not going to be as nice because y isn't already solved for. We're going to need y to be solved for before we enter it into the equation. So let me start with that top equation, and let's solve for y first before we enter it into our calculator, okay? So for 4x plus y equals negative 3, the thing that needs to move over is the 4x, so I'm going to subtract 4x from both sides. That's going to cancel, and I'm going to end up getting y equals negative 4x minus 3 for my first equation. Now the second equation, I'm going to have to do a couple steps to get y by itself. I got 3x minus y equals negative 11. I'm going to start by subtracting 3x from both sides. The 3x's will cancel. I'm going to get negative y equals negative 3x minus 11. Now I'm going to have to divide negative 1 from both sides because when you have a negative y and you're trying to get rid of that negative y, it's really just imaginary ones just kind of chilling there. So you're going to divide each side by negative 1, okay? Which means each of these parts on the right side that needs to be divided by negative 1, meaning for the most part you're just changing the signs, okay? So pretty much what we are left over with is y equals a positive 3x plus 11. Okay, so my 2 equations are y equals negative 4x minus 3 and then y equals 3x plus 11. So I'm going to have to graph both of these and see where they intersect to find out the answer to this system of equations. All right, I'm going to go to my home screen. I'm going to open up another graph page and I'm going to go ahead and type those in. Okay, so y equals negative 4x minus 3 is that first one. I'm going to graph that. And then the second one, I got 3x plus 11, so I'm going to hit tab. I'm going to go over and hit 3x plus 11 on my calculator. And there's my second line, okay? I'm going to just move my screen over by clicking, dragging, and moving it over until I find my intersection point. And I'm going to repeat the process I did that first time, hitting menu, going to analyze graph, going to, where is it? There we go. Intersection. I'm going to get my lower bound, my upper bound, and what do you know? There is my point, negative 2 comma 5. So the answer to this system of equations is just going to be negative 2 comma 5. Okay, and there we go. So that's example number 2. Let's do example number 3 real quick. Example number 3, again, we're going to have to solve, okay, so let's go do this quickly. I'm going to start with the bottom one here, okay, so I'm going to start by adding 6x to both sides, and I'm going to be left with 2y equals 6x plus 2. I'm going to then divide each side by 2. And then to simplify, I'm just going to take each of those segments, 6x and 2, and divide each of them by 2. So 6 divided by 2 is going to give us 3x. And then 2 divided by 2, that's just going to give us the plus 1. So our first equation is 3x plus 1. Let's do the second one real quick and solve for y. I got, let me rewrite that, 3x minus y equals negative 4. I'm going to subtract 3x from both sides. 3x's cancel. I get negative y equals negative 3x minus 4. And if you remember from last time, when I divide each side by negative 1, it's pretty much just changing the signs. So for the most part, skipping ahead, I'm going to end up getting 3x plus 4, okay? And if you don't believe me, you can go ahead and check that out yourself, okay? So we're going to graph these two, y equals 3x plus 4, and y equals 3x plus 1. And let's look for the intersection between these two lines, all right? Let's go ahead and get another graph going. Let's go ahead and start with the first one. So 3x plus 1. Awesome. All right, and then let's do the other one, which is y equals 3x plus 4, all right? So let's see here, tab, 3x plus 4, shaboom. Alrighty, now I'm going to go try and intersect, but wait a second, let me zoom out a little bit. If you notice, these lines look, and you guessed it, parallel, which means they're not going to intersect. Well, what does that mean for our solution? Just like when we were going ahead and doing linear equations and you ended up with a number equals another number and it didn't match up, we called that no solution. Well, this is the same kind of ordeal, okay? When you have two parallel lines and they don't match up, we are going to say no solution, or the answer is undefined. So this example is undefined, all right? Let's go on to example number 4. Last example of the day. All right, here we go. 5x plus 2y equals negative 4, and 10x plus 4y equals negative 8. Making me work today. All right, let's move this 10x over. We'll start by moving that and getting y equal to itself, or y by itself. Got to learn how to talk today. All right, here we go. So negative 10x, doodly doop doop doo. All right, I got 4y equals negative 10x minus 8. Hot dog. I'm going to divide each side by 4 now. Okay, now let's see here. I got y equals, now negative 10 over 4. I'm going to reduce that by dividing the top and bottom by 2. So that fraction pretty much becomes a negative 5 over 2x. And then negative 8 divided by 4, well, that's just going to be a negative 2, okay? Now, the other equation, let's go ahead and solve for that. Let me rewrite it. I got 5x plus 2y equals negative 4. I'm going to subtract both sides by negative 5x. Okay, so negative 5x. The 5x's cancel. I get 2y, don't forget the bar, 2y equals negative 5x minus 4. Okay, I'm going to divide each side by 2. Divide that by 2. Those 2's will cancel. Alrighty, now this one's going to be a little easier to simplify for the fraction because it's already negative 5 over 2. The other one we do have to divide, and that's negative 4 divided by 2, which again is going to give us negative 2. So what you'll notice is, ooh, there we go. This is interesting. We got two equations, and both equations are the same. Holy moly. So what you can expect is when I graph this equation and I graph the other equation, I'm going to get a line on top of a line. Now, I'm not even going to show you that because you can probably guess that this just has a line over a line, which means that any point that I plug in, the output is pretty much going to be the same for both of these graphs, meaning I have an infinite solution. So anytime you have a graph on top of another graph when you're doing system of equations, you can go ahead and call that infinite solutions. Okay, well, that's it for today. There's 4 examples for you. You can go ahead and use your calculators to help you get these graphs of system of equations. Hopefully that helps you a lot, helps me a lot. And again, the 2 weird instances are if you have 2 parallel lines, you're going to say no solution, or the answer is undefined. Or if you have 2 lines on top of each other, we're going to go ahead and say that we have infinite solutions, or all real numbers as our solution. Okay? Have a great day. I'll see you later. Bye-bye.